Okay, we're going to look at the practice multiple choice for the Integrated 3 midterm. These are questions 1 through 5. So the first one deals with parent graphs. So you got to recognize the parent graph right here, well, that is y equals 2 to the x. Now, if you didn't know that, it should be obvious because of all the answers. So when I'm thinking about how my graphs are shifted, when I work with 2 to the x, I need to think about how the graph was shifted upward. So I can see a horizontal asymptote right here. So that tells me the graph was shifted up 2. Now what I got to do is I got to locate where is the point where it's 1 unit above. That's my locator point. That happens at x equals 4. So that tells me the graph was shifted to the right 4. Well, if it's up 2 and right 4, remember shifts left and right kind of work backwards because we're relocating where 0 is. So that means my equation is y equals 2. This is like having parentheses up in the top. If I shift to the right 4, it's x minus 4. Then up 2 would be plus 2. Therefore, my answer would be C. Questions 2 and 3 deal with domain and range. So remember, domain is my possible values for x. My range are the possible values for y. So we're going to do domain first. So we have right here, we can see the x values are starting from -5, and then they go on forever. So at my low end, if I'm going to do interval notation, my domain is -5, and it's going off to infinity. So I have an open circle here, so that's the way this one looks. So if it was a closed circle, I'd have a closed bracket, -5, turning up, and then the arrow points that it keeps going on forever. So I'm going to translate this to inequality notation. And the inequality notation is structured in the way that it matches the interval notation. So it should be -5 is less than x is less than infinity. Never get equals with infinity. So I look for this. Well, it's not that one. That one has equals. These are -1s. So this is a case of a none of these. Okay, now we're going to look at the range. Okay, so when I look at range, these are the y values. So imagine kind of drawing out a box. If I was to structure this, this is what it looks like. Now, it does hit that bottom spot. So my lowest point on my y values is -1. It goes up to, but does not include the value up here at 4. So for my range, I am going to go from -1, this time I have a closed bracket, up to 4, but I'm not including it. So translating that, that is -1 less than or equal to y, which is, -1 less than or equal to y, which is less than 4. So going over find that answer was C. Okay, now we're going to look at working with inequalities. And I'm going to find all the inequalities that will produce the region that is shown. So this is really, again, testing parent graphs, because the only additional thing is whether it's shaded above the graph or below the graph. So we're going to look at each one of these. First, I'm going to look at this V-shaped graph. You should recognize that as the absolute value. So I can tell right here, I'm looking for the vertex. I'm going to look for the vertex on both these graphs. But the vertex here is shifted to the right 2, because this point right here is at the point 2 and then 5. So that tells me for my absolute value, it's right 2 and up 5. So when I go to write my equation, It's going to be a flipped graph, and it's flipped. So it's y, and then I must work with the equation initially, equals negative absolute value, right 2, x minus 2, up 5, plus 5. Again, the negative was because of the flip. Now, okay, so I see both of those, so it didn't really help me. I got to think about how the shading is. The shading is below the graph. Now, I can always test it by plugging a point in the shaded region to see if it actually works. And that would be okay. So if you plug in any point in the shaded region, for example, let's say if I plugged in the point 3, 2, this is going to have to be true. If I plug in 3, 2, I'd have 3, then I have negative, and I plugged in y value, if I plugged in 3 for x, sorry. So I plug in 2 for y, and then 3 for x, I'd have negative, absolute value of 1 plus 5. So I have 2, and over here I have 4. 4 is greater than 2. 4 is greater than 2, so therefore I'm going to use the less than sign. This sign was A. Now, another way I like to look at it, the shading is below the graph, less than. But you can always do it by testing points as well. Okay, let's look at the parabola. The parabola is sitting on the x-axis, so it's only shifted left or right. It's shifted to the right 3. So if it's right 3 and it's right side up, it's x minus 3 squared. That's the equation of my graph. It's shaded above it, so it should be a greater than. Now again, I could test that same point that was in the region. We wanted to use the point 3, 2. So 2 is greater than or equal to 3 minus 3 squared. That equals 0. 2 is in fact greater than 0, so that is true. That just gives you another option for being able to test it. Okay, let's take a look at question number 5. Okay, the y-intercept of a parabola has a vertex at negative 3, 5 and then passes through the point negative 5, 3. Okay, so my vertex, that tells me this is shifted to the left 3 and up 5. So I go y equals a x, opposite here, plus 3 squared plus 5. I need to figure out what a is. So I'm going to use this other point to solve for a. So plugging in, I got y is 3, x is negative 5. So 3 is equal to a times negative 5 plus 3 is negative 2 squared plus 5. So I get 3 is equal to 4a plus 5. I get negative 2 equals 4a. A is equal to negative 1/2. Okay, so now my equation, I get y is equal to negative 1/2 x plus 3 squared plus 5. I want to find the y-intercept. The y-intercept happens when x equals 0. So I get negative 1/2, 0 plus 3 squared. So this is 9, so I get negative 9 halves plus 5. Well, that's negative 4.5 plus 5. That equals 0.5. So my answer for that one was C.